Hello, students who want to succeed. In this video, we are looking at question 9 of the IGCSE Paper 4 Extended, Variant 3, May-June 2024 question. So let's look at this question is on magnetism, and then it's looking at the new technology of charging phone without a cord by placing the phone on a flat charging plate. So figure 9.1 shows a mobile phone being charged with a wireless charging plate. So in this case, you have two basic coils. So you have the coil from the primary plate. So you have this coil here. So we can call this one PI. Then we have the secondary coil. Then this is the primary, and then this is the secondary coil. So if you look at this, let me call it P secondary. So let's call this one the secondary coil. That is the part that comes from here, secondary. Very good. So when the charging plate is switched on, there is an alternating current. So the current that flows into the primary coil is an alternating current. There are two types of current. So when we talk about alternating current, we are talking about a current that fluctuates. So like alternating current, you have this. So this is what we talk about. We are looking at the current I as a function of time. So the value varies. So it's an alternating current. So the current that comes here, so it's power with an alternating current source. And then when that happens, this is going to produce a magnetic field. So let's call this the magnetic field, and then the magnetic field line will cut across. So we have the feed line. Okay, so let's assume is this. Okay, so this magnetic field line, when an alternating current flow into the primary coil, it creates a changing magnetic field that cuts the secondary coil. So explain how current is produced in the secondary coil. There are 3 steps. So basically, the first step is AC. Let me use a smaller pen. AC current flows into the primary coil, flows into the primary coil. Okay, producing changing magnetic field, producing changing magnetic field, which cuts the secondary coil in the phone. So as this changing magnetic field cut the coil in the phone, it will induce, so thereby inducing current in the phone. So this is how the current. Now, B part, the maximum energy stored in the battery of the phone is 0.012 kilowatts. Now, if you look at this, yes, the secret formula for energy is equal to VIT. So what will happen here? VI is power, so which is the same thing as PT. The power is the kilowatt, then the time is the hour. So if you have that, so all we need to do is to convert this to joule. So the energy for full capacity is equal to 0.012, so times kilowatts, that is times 1000, then times 1 hour, 60 minutes, convert it to second. So this will give 43,000 joule. So we finish that. Then the next one that we need to look at is the charging place, in figure 9.1 has a useful output power of 15 watts. Now, the phone manufacturer claims that the battery can be charged to 50% capacity in less than 30 minutes. So, what we want to show here is that the time taken to charge the battery to 50 capacity is less than 30 minutes. So we want to prove that the charging time is less than this. So we are going to look at, so what do we do in this case? So let's look at, so first of all, we know that the output power, P output, that is the power in the phone, is 50 watts. Okay, that is the output power. Okay, so once we know the output power, if we multiply by the time, it will give us the energy. So let's look at the phone. What will be the energy in the phone when it is 50% capacity, 50% capacity charged? When it's 50% capacity charged, that means the total energy here, half of it, that will be half times 43,000 joule. So which is equal to 21,500 joule. Okay. Now, oh sorry, okay, this is 50% capacity. Very good. Okay. So now let's look for the time. Let's calculate the time that it will take this energy to be stored at this rate. So what is power? Power is equal to energy over time, the rate of energy dissipation. So if we want to get time of charging, equals to energy over power. So which is equal to 21,500 joule divided by 15 watts. And this will give us 14.33 seconds. So convert it to minutes. That will give 23.8 minutes. Okay, very good. So once you know that 23.8 minutes, so we have proved that the time taken for it to charge to 50% capacity is approximately 24 minutes. So now let's assume that, so if it is fully charged to 50% capacity, so if it is charged for 30 minutes, what will be the energy? So energy stored in the phone. So okay, let's look for energy stored in the cell phone in 30 minutes charge. Okay, so that will be, so the energy stored is going to be power PT. So what's the power? 15 watts times 30 minutes. So 30 minutes, so multiply by 60. So that is going to give 27,000 joule. So what is this capacity now? 27,000 joule. What capacity is 27,000 joule? So let's look at percentage charge. What percentage charge will be that for 30 minutes? So let's see, percentage charge is going to be energy stored over the full capacity. So energy stored over the full capacity times 100%. So that would be 27,000 over 43,000 times 100%. So that would be 62.7%. So if the phone is charged for 30 minutes, the battery will be charged to the capacity of 62.7%. So the manufacturer is correct. So subscribe, like, and share. So I want you to, we'll go to the next video. The next video is going to be on question 10.